Uno, dos, tres, cuatro.
Hi everyone, today we're going to take a look at circles. So it's the real start of our conics unit. Last class we looked at linear relations, which was a review for Math 10. Circles is brand new to Pre-Calculus 12, and it's really the start of conics. So if you want to think about in terms of what conics are, we're going to extend what we've learned from transformations in the past, and we're going to learn how to translate, reflect, expand, compress, do all the things that we've learned with transformations to different conic shapes. And conic shapes can include circles, which we'll look at right now, but it's also going to include something called hyperbolas, ellipses, and parabolas. And I know we've studied parabolas a lot in Pre-Calc 11, but we'll be able to look at sideways parabolas as well. And so to get a better understanding of conics and how circles work, we have this diagram here that you're going to see a whole lot over this unit, and it shows what happens when a plane cuts a cone at different angles. And if you want to take a look at scrolling down here, I'll just give you a quick sneak preview, and this is probably the best way rather than me trying to draw something. When you have something in which the plane cuts a circular cone perpendicular to the axis, you create something that's going to make a circle, and that's different from some of these other shapes that you're going to see right here. And this may be quite strange to look at something from in this sort of dimensional angle, but what you could also vision is just what it would look like on your traditional X and Y axis. And for circles, I think it's something that we've been curious about, and I know we've alluded to in terms of some things that you could graph that could form a circle, and we're just going to expand on that a little bit today. So if you are overwhelmed by looking at this diagram here, then I think you'll be put at ease when we start to actually go through some of the questions. Now, if you do want to take a look a little bit more at conics, we have a link right here from a video that I think will help explain conics a little bit more. But in general, we can say that conics are going to take on this form: ax squared plus cy squared plus dx plus ey plus f equals 0, where A, C, D, E, F, those are going to represent parameters, and we're going to put in different values right there to be able to move them around, and then based from that, we have our X and Y's that are going to tell us what shape we have. Okay, so let's get started, and let's just do a quick review of circles. And if anything, this may actually remind you a little bit more of trig than anything else. So we'll start off with our most basic circle, in which we have the center at 0, 0. And if you have something like that, imagine what would happen to create a radius. So right here, we'll say that this is an unknown point. We'll call it the point xy, and if we wanted to figure out what the radius is, think back to what we learned about finding the distance between 2 points in 8.1. We could create a right angle triangle to create our Pythagoras, and we have an x value here, and we have a y value here. And if we wanted to think about what that would be as a Pythagorean statement, you could say something like this: x squared plus y squared is going to equal the radius squared. And that's going to be true for any time you have a point at 0, 0. Now, that's our basic shape, and we haven't translated it away from the origin. But if you look back up here, up top, you can start to see that now we're actually creating parts of the forms of conics for what we would look at. We have an x squared value, a y squared value. It just so happened that d was 0, e was 0, and then we brought f onto the other side. But you can start to see how this could create something of the form that we're talking about. So given this 0, 0 example, let's just get used to what this would all look like. question number 1, write an equation for something that has a radius of 5 and passes through the point 0, 0. So if we have something like that, we don't have to think much further than to say x squared plus y squared equals 5 squared. And then let's just say x squared plus y squared equals 25. Now, if you want to see what this looks like by graphing it, I would recommend 2 things. You could, probably number 1, go to Desmos and type in x squared plus y squared equals 25, and instantly you'll be able to get this circle with a center of 0, 0 and a radius of 5. If you wanted to put this into your graphing calculator, it's much more complicated because you have to isolate for y, and when you isolate for y in these situations where you have a y squared, you'd be creating a plus or minus situation, so you'd have to put in something for y1 and for y2. Part B, write the equation of something that passes through the point, the circle passes through the point negative 3, 2. So we don't know what the radius is in this case. And you could say something like x squared plus y squared equals r squared. And we know a point with an x and a y point that we could sub in to be able to solve for r. So let's do that right now. If where I have an x, I can replace it with a negative 3, and where I have a y, I can replace it with a 2. And now we can solve for r. So you could say 9 plus 4 equals r squared. So 13 equals r squared. Now think about what the question is asking. It's saying write the equation of the circle. And so if they want just the equation of the circle, it would be x squared plus y squared equals 13, because it's in the form of r squared. If they asked a follow-up question and they said, well, what's the radius? The radius itself, though, would be, well, r squared was equal to 13, so therefore r would be equal to the square root of 13. They're not asking for that, but it's just good to be able to know the difference between those 2 types of questions. Okay, so now let's start to put in our transformation ideas, and let's start to think about a prediction. What would happen if you move things around? And so we're going to say a horizontal translation of the circle is going to be represented by moving it left or right by h units, and shifting up or down would be by k units. And so if you had something like that, pause the video right now, and could you come up with what you would see as the standard equation of a circle with center hk? So I would predict most of us probably had something like this: x minus h squared plus y minus k squared equals the radius squared. And this is our standard equation for a circle. And that's what happens when you have center h comma k. So given something like that, let's see if we can figure out something where it would say determine an equation for this circle below, and it looks like the center here is at 3, 2. And not only is the center at 3, 2, let's see if we can find out anything more with it. Do we know the radius? It looks like that it expands out over here, and it looks like that's right at 8. So if that's the point, say 8, 2, then it looks like we have a radius of 5. If you count up, it goes up to 7, which would confirm that we have a radius of 5 for sure. So we'll say our radius is 5, and that's something that we can feel confident on. So based off of this, we could say x subtract 3. We've gone 3 to the right, and we've gone 2 up. Okay, so if you've gone 2 up, then we would say something like this. And then it's going to equal, you could say 5 squared, or if you want, you could say 25 right away. And I'll give you guys an option. So I'll just rewrite it right here. Okay, so this means we've gone 3 to the right. This means we've moved 2 up. Okay, so it's just like our same translation characteristics that we would have learned from our transformations chapter. Determine the equation of a circle with a center of 3, -1 that passes through the point 7, 4. So we could say x subtract 3 squared plus y plus 1 squared equals r squared. And it passes through the point, an xy point of 7, 4. So wherever there's an x, let's put in a 7, and wherever there's a y, let's put in a 4. So we could say 7 minus 3 squared plus 4 plus 1 squared equals r squared. And let's solve for r squared. So 4 squared is 16 plus 5 squared is 25. So r squared is going to equal 41. So we could write this out and we could say x subtract 3 squared plus y plus 1 squared equals 41. Part B, show your solution in part A in the form where we can now say that we're going to expand this. So if we want to write this in general form. Now you might be saying, what's this extra stuff that's happening right here? Let's write it in expanded form first, and then we'll address that. And so expanded form is just, let me just write out our original form here. It's just going to be foiling everything out and joining like terms. So we could say something like x minus 3 squared is saying x minus 3, x minus 3. So if we expand that out and join like terms, we get something like this. And y plus 1 times y plus 1 would be y squared plus 2y plus 1. And we want to get everything onto one side, and we want to put it in the same order that they have for general form. So we could say x squared plus y squared subtract 6x plus 2y. And then think about this, we have 9 plus 1, so we have 10, and then we're going to, with that 10, we're going to subtract 41 because we have to bring this 41 over. So if we subtract that, we would have subtract 31 when we join like terms, and you would get something that would say this. So hopefully that's what you got as well. Now, they're saying where a and c are greater than 0. And so think about this. Here's your a value. Here's your c value, or a value is 1, or c value is 1. And what they mean by that is they want you to bring everything to create something where those would be positives. They don't want you to start off with something in which your a value, for instance, would be a negative value. So in other words, bring everything to the left side in this case, don't bring everything to the right side. And that's just the form that it's written in. And then they're saying where a equals c, meaning that you want to have something in which your a value in this case was 1 and your c value in this case was 1. And it has to be the same, because if they are different, you could probably make the prediction that if A and C weren't the same, then there would be some sort of vertical expansion or compression, or some form of horizontal expansion or compression, and then it would no longer have the characteristics of a circle. In fact, that's what we're going to learn next class when we start looking at ellipses. Example 4, find the center and radius of something that's in general form, and they actually would want us to put it back into our graphing form. And if we can put it into graphing form, then hopefully that's going to help us out a little bit to be able to find these characteristics. Now, think about this, and think about the math that you've learned in the past couple of years of how you could potentially go from our expanded general form into this graphing standard form. How would you change that back into something that's going to have our brackets? And I don't know if you guys are thinking about this, but think about something from pre-calc 11, and you'll probably remember that you spent a decent amount of time completing the square. And if you recall the characteristics of what you had to do to complete the square, we're going to be able to do that here to be able to create the form that we need to have it in. So the first thing is we need to rearrange things, and you probably need a refresher on completing the square. But I'm going to write my x's next to each other. So I'm going to say x squared subtract 14x plus y squared plus 6y subtract 6 equals 0. And let's think about what we need to do to complete the square. Hopefully this doesn't go too quickly, but we'll open up a bracket, and there's nothing to factor out because we know that there's just a 1 in front. So if there was a coefficient from the x squared, you would have to factor that out. So x squared subtract 14x, and then let's go blank blank, okay, plus bracket y squared plus 6y blank blank minus 6 equals 0. And we have the two blanks in each of them because whatever you invite, you have to contrast it with its opposite. And so if you remember how to create a perfect square trinomial, you took the middle value, the negative 14, in this case right here, you take half of it and square it. And so if you take negative 14 and you half it, you get negative 7, and negative 7 squared is positive 49. But then whenever you have a positive 49, you can't just throw that into an equation. Algebraically, that doesn't make sense. So you have to balance it. So you put in a negative 49. 100% of the time, it'll be the positive version first, and then the negative version following. So for your second bracket here, if you take the 6 and you take half of it, you're going to get 3, and 3 squared will give you 9. So you get plus 9 minus 9. If you had me for pre-calc 11, I had this strange analogy about bringing in these positive people to the party and then bringing in these negative people to the party, and the negative people get kicked out of the party. And so this negative 49, he has to go, and we kick him out. And this negative 9 here, he has to go, we kick him out. And every single time when creating these perfect square trinomials, we're going to boot that negative value, and then we're left with something that we can factor. And so we'd have x minus 7 squared plus y plus 3 squared, and then negative 9, negative 49, and negative 6, they could all be joined together. If we join that, what do we get? We get negative 15, negative 64 equals 0. And look at this, we're just about done. So if we have that negative 64 over there, we can add it on to the other side, and we should be able to answer everything that we want for this. If you need more of a refresher with completing a square, you're saying, this seems really, really strange, I'm not sure what you're doing here, make sure you ask me in class and we'll be able to answer that in a whole lot more detail. Now, they're saying, what are the coordinates of the center? So we've gone 7 to the right, and we've gone 3 down. So we would say 7, negative 3, and that's our center. And then our radius, r squared is equal to 64, which means our radius would be the square root of 64, which means our radius will be 8 units. So this idea of completing the square, I don't want you to think that this is a one-off question and you're not going to see that again. You probably thought in pre-calc 11, hey, I'm done with completing the square. I don't need to worry about that anymore. It's going to show up again and again, and you're going to need to do it for sure with hyperbolas, and you're going to need to do it with ellipses. So if it's something that you're rusty with, make sure you keep working on it and ask some questions. Okay, example number 5. It's a little bit of an odd example because it doesn't look like anything familiar to us. So it's saying, sketch part of a circle given by this equation. And if you look at part A, it would say, it would look like something where maybe we don't even know where to start here, but we're actually just about one step away from having something that's going to really, really resemble a circle. If you were to do some algebra here to tidy this up, what would happen if you squared both sides? So if you did something like that, you would have y plus 1 squared equals, well, the square root that was over the entire right side would reduce with the squared. So you'd have 9 minus x minus 2 squared. And if we then don't expand, but rather we add this x minus 2 squared onto the left side, then you could create something that could say x minus 2 squared. So we've added that onto the left side, plus y plus 1 squared equals 9. And sure enough, that is a circle. And it's a circle with a center of 2, -1. And it has a radius of 3. So you could go up 3, and you could go down 3, and you could go to the right 3, and you could go to the left 3, and we'd be able to fully graph that. And I'm going to start by fully graphing it, but then we need to reevaluate what we've done here. Okay, so everything looks really good, and I would say that that looks fully complete, but I want us to think about restrictions. If we were just asked to graph this final part and we never had that square root, then I would say we're done. But when looking back at that original part right there, I want you to think about values of x that are allowed and values of x that are not allowed, and think about what you could put in here possibly for things that could give you a negative square root. And in other words, what I want you to do is I want you to think of a top half and a bottom half. And if you had something, well, let's pick this point right here. I'm just going to look at 1, 2, 1, 2. Okay, so here's the point 2, 2, and I'm just going to pick this bottom point down here. So this is the point 2, and then -1, so -2, 3, 4. Okay, so we have something like this here. So imagine what would happen if you had the point 2, -4, and if you tried to sub that in, what would show up with your original? So why don't you pause the video right now, think about it, and see if you could figure out which half of the circle remains and which half of the circle needs to go away. Okay, so hopefully you've thought about something like this. I have a square root on this right side, and I know that this y plus 1 would only be defined when it's greater than or equal to 0. And that's because I know that nothing but a square root would produce something that's either 0 or positive. So y plus 1 must be equal to something that's going to be greater than or equal to 0, which means y would only be defined when it's greater than or equal to -1. And so if you think about the circles and we're looking at that top half and that bottom half, it's only defined when it's above -1, which means that this bottom half right here, in this particular case, does not exist. And we only have something that would be the top half of that circle. And so our domain is everything from -1 to 3, 4, 5 to 5. And so you could say something like -1 to 5. And then our range would be everything from -1 to 2. So definitely a strange example. I don't know if this part B is going to be much better, but let's see what we could do with it. So if you're like me, you would probably say step 1, let's square both sides. X minus 2 squared, is going to be equal to 9 minus y plus 1 squared. Okay, so then let's add the y's onto the other side. You could say x minus 2 squared plus y plus 1 squared equals 9. We have a circle. Let's graph the full circle again, and let's see what we could do with it. So you get the center would be 2, -1. And once again, you have a radius of 3, so you go up 3, down 3, over 3, over 3, and we create this circle. Seems really easy. We got the same thing, but now let's look at our restrictions. And your restrictions here would say something like this. This x minus 2, well, it's equal to this right side, and this right side, well, I know my square root has to always be something that's producing something that's 0 or positive, so greater than or equal to 0, but it's being times by a negative sign. So instead of saying greater than or equal to 0, I would actually, in this case, have to say it would be everything less than or equal to 0. And so that means that x is going to be everything less than or equal to 2. And so when looking at your center here at 2, -1, and it's defined for everything less than or equal to 2, it means that your x's now have the restriction where it's just going to be this half of the circle. And so your domain would be everything from -1 to 2. And your range would be everything from -4 to 2. Those are, I mean, that's a pretty obscure question, but overall, hopefully, the idea of being able to graph circles seems pretty reasonable. And that's your first real intro to conics. Thanks. Actually, I'm back. We have a little bit more. There's a couple extra practice questions right here. So here's just a couple questions that you could see on a traditional assessment if you wanted to take a look at that. If you want to watch someone try to draw a perfect circle, this one's pretty good. It's an old YouTube video, but it's not bad. And if you want to jump straight to the homework, you can do that. But let's go through these two extra practice questions. So it says, determine the equation of the circle that has a center of 4, -3, and passes through the point 2, 1. Okay, so without even looking at the options, we know we could say something like this: x minus 4 squared plus y plus 3 squared equals r squared. You could probably cross off some of the options almost right away. Actually, you know what? Looking at this, I guess you probably would say, well, isn't there only one case in which that's the case? So I think it has to be D. But let's confirm this. It passes through the point 2, 1, so an x and a y. So we could say something like this: 2 minus 4 squared plus 1 plus 3 squared equals r squared. And let's confirm that we get an r value of 20. And sure enough, we do. So then that's great, because then we know that it would have to be D. Question number 2, determine the radius of a circle that looks like that. Okay, well, this is a good question because we have to complete the square, and it's not super obvious that that's what we have to do. So let's just put it in the order where our x's are together and our y's are together. And you get x squared minus 4x blank blank plus y squared plus 2y blank blank equals 0. We invite in a plus 4 and a minus 4, and we invite in a plus 1 and a minus 1. We got that by taking half of the b value and squaring it. We kick out the -4, and we kick out the -1. And if we did something like that, we would get -5, add 5 onto the other side, and r squared would be equal to 5, which means r would be equal to the square root of 5. Make sure you know the difference between these two concepts. So that means r would be equal to the square root of 5, so we have a right there. Okay, that's it for our intro to circles for sure this time. Thanks.